So in today's video, we are going to look at time series forecasting using Arima model. Now, a very good place to start to learn machine learning is actually through Bigquery, because I feel they have all the latest models. And if we just read the documentation, we get to learn a lot of things that happens under the hood when it comes to Bigquery ML. So in today's video, we are going to look at how to do this Arima modeling for time series forecasting in Bigquery ML. And before we jump into Bigquery, I also want to look at a very basic example by looking at dummy data in Python. And doing Python and Bigquery will be a really good exercise just to see how building models between these two tools differ. And maybe in the next section, I'll also try to integrate maybe the stock prices, the interest rate, and GDP data and create a multivariate time series forecasting in Python and also in Bigquery. So let's get started and see how far we get with this. So within Arima, there are basically three different parameters. So the first is AutoRegressive, and then we have integrated and moving average. And before we jump directly into Python, I want to make ourselves familiar with what these three parameters are and why exactly they're there, and maybe also look at some real world examples of using these and not using these and the consequences of not using these parameters, right? So autoregressive basically means it is dependency of the current observation on its past, right? So if we take an example of, let's say, stock prices, so today's stock price value might actually depend on previous days stock price or maybe previous 30 days stock price value, right? So how far back do we want to look at in our data set to actually forecast into the future? So this particular term, if we say p equals 1, then we just want to look at one previous value to forecast the next value. Or if this is 30, and in a case with stock prices, we look at past 30 days to predict or forecast the next value. Another example might be forecasting electricity consumption. So imagine the electricity consumption at, let's say, 7 p.m. is actually dependent on the electricity consumption that was at 6 p.m. or 5 p.m. Right? So there's actually dependencies between the forecast value and the past value. So that's just a really simple example of autoregressive part of Arima model. And next is integrated, where we basically make the time series stationary. This is really important to avoid overfitting or underfitting, and also to help Arima model basically do its job in time series forecasting. Because if let's say we want to forecast the inflation rate, right? And if the inflation rate is going up or down, now there's a trend. And if there's a trend, then Arima model might not pick up all the relationships within the model to predict the future or forecast the future. So let's take this example that I have over here. So this basically obviously has a trend line, doesn't it? So it's going up in trend. Now, if we want to use this in Arima forecasting, what we basically want to do is convert this into a stationary plot, if you will. So the trend line would look something like this. And that is what integrated does. It makes the non-stationary plots into a stationary plots, right? And then finally we have the moving average, which is just the relationship between the current observation and the past error terms. Now, as an example, let's take inventory forecasting, where in an e-commerce business we want to forecast what inventory we want to hold for the next upcoming holiday season or the next year. Let's say we have the data set of past 5 years, and in those 5 years there were some spikes, and that might have been due to promotions or some unexpected event and so on. And for Arima model to actually understand the relationships between all these spikes or dips and the promotions and unexpected events, we use moving average so that all these relationships can be understood by the model. And maybe if we take an example of weather prediction, there could be some instances where there might have been weather changes or holidays and other things as well. And if we use moving average, all these relationships can be caught by a Arima model. Now in this next section, I just want to go over a really simple example. This is not even a real world test data. It's just some random data that we're going to produce in Python and then see how we can model this with a very basic example so that we get started with doing some modeling, right? So let's get started. So I'm using my VS Code to run this Jupyter notebook. You can even use other tools like Google Colab and other things if you have access to that. And basically in my environment, I've installed all these packages, NumPy, Pandas, Stats Model, Scikit-learn, and so on. And let's just build a very small data set of test values that we can build an Arima model on. So I'll start by importing all these packages, NumPy, Panda, Stats Model, which has Arima model in it, and sklearn metrics, where we are going to use mean squared error, and we are going to also plot some graphs using matplotlib. And this would be my data. So this is again, like you see, as you can see, this is just a random set of numbers, and let's call this monthly sales. And let me just run this, and then we'll split this into test and training set. So for this, we are going to use the train test split functionality from sklearn model selection. So here we are just saying that the test size should be 0.2, or 20% of all these numbers would be assigned as a test data set, and then everything else, or the 80%, will be used for training. And we'll see that in a minute. So if we just run this, so now we have train and test. So I can just print this out. So these are the numbers, and this is a training set, and then this would be a test set. Again, this is not real world example. I just want to get started with doing some Arima modeling just to see what parameters and everything are involved in building something like this. And then we'll move on to BigQuery ML as well. To actually build the model, we use this Arima model, which comes from stats model package, and we give it the training data set. And in order, we are using is 111. If I just look at all the parameters that Arima model takes, if I just put a comma here, VS Code will auto populate all these other parameters that can be put into Arima model. And as you can see here, these are all the parameters. Now let me go into this function itself and see what other parameters are there. So basically we have all these like P, Q, and D terms, which is here integration models Arima PQ, PDQ, which is similar to what we had here, P, D, and Q. We just specify all these orders. And for now, we'll just leave it as 111, and we'll see what effect this has. And basically in real world, what we want to do is we want to find out what is the best model that we can use, what are the best parameters we can use here. And we'll do that when we get to BigQuery ML, where all this is taken care of BigQuery. And here we just use this basic model 111 and see how far we get with this. And if I just run this, we have the model. Let's also do a model.fit. And now we are ready to do some forecasting. So the model.fit, we can use this to forecast all the values, and we are going to forecast the number of test items that we have so that we can compare what the actual value was against a predicted value. So if I just run this, we can also get the mean squared error. So obviously this is not a good model because these are just random numbers, but this is how you get mean squared error. And let's finally plot what these values look like. So here we can plot the test data and call it the actual values, which would be from this data set over here. And then we'll also plot the forecast values that we got from this step over here, and then we'll call it forecasted. And then we'll show these plots. So if I run this now, so this is the actual value and the forecasted value is just this. Now, obviously this is not a really good example, but I just wanted to write this example in Python to see what are the steps we would need to take to run this very basic model in Python. Now, there are various other things that BigQuery does. So let's look at that next and then see what are those steps that we are missing in our Python model. So if I just go into the documentation of BigQuery, where we can see the create model, I just want to look at what is Arima Plus that BigQuery offers. And these are some of the things that BigQuery does when we start using the Arima model within BigQuery for time series forecasting, and they call this Arima Plus. So if we just go down this list, they say infer the data frequency of time series and handle irregular time intervals and handle duplicated timestamp and so many other things that BigQuery does by default. And those are the things that if we were doing in Python, we would have to do manually. So that is why I feel like learning BigQuery and BigQuery ML and understanding the documentation is really good start if you want to also take this knowledge and then do something in Python, because now we know what are the exact steps that needs to be done when we want to get a really good model in Python, and we are just getting started with these time series forecasting with Arima modeling, right? So these are some of the things that happens by default within BigQuery, and this is really good because we don't have to worry too much about these things. Now let's look at example data set and also build the model, do some forecasting, also build some plots within maybe Data Studio or Looker Studio and see what results we get there. And instead of typing all this out, let me just copy and paste this and explain what's happening. And then you can pause at relevant section and then try this on your own. Or I'll also include a GitHub link in description so that you can go and try this code by yourself. So here we are looking at BigQuery public dataset, and specifically we are looking at Google Analytics samples, and then we have some sessions data that is available to us via this BigQuery public dataset. And in here we are basically interested in the date and the total visits. This would be our time series data. Now if I just run this by pressing Command Enter, we will see what this data set looks like in a minute. So this is how the data set looks like. It is from 2016 all the way, it goes up to 366 values. So a quick way to visualize how this original data looks like is to just click on Explore with Looker Studio. Now I do like the integration between BigQuery and Looker Studio, but I feel sometimes this takes a while to open up. So we'll just see how long this takes. Okay, so this has opened. Let's just convert this into a time series chart. Let's add a dimension. Okay, so we have a time series graph here. Let me just make this big. So this is how our data set looks like. So these are all the total sessions from 2016 to 2017. And I guess there is some seasonality here within the day itself, or no, within the week perhaps. So let's see how we can forecast some of these values within BigQuery ML. So if I just go back here, let me make this smaller. Let me comment this out, and then let's create a model based on this data set. So let's first do create or replace model, and I'm just going to save this as Arima GS sessions. The options I'm going to give are as follows. We'll call the model Arima Plus, and we are going to give it a timestamp column and a data column. Right now, if we look at the previous SQL query that we executed, our timestamp column is called parse state, and the total visit is our column that we want to forecast. Now we'll also give the actual data set here in a minute, and let's just understand these parameters first. So we have the AutoRegressive equals true here, and if we jump into the documentation to understand what exactly this means, we have a blob of text that Google provides us. Basically it says if the value is true, training will automatically find the best non-seasonal order for P, D, and Q. So if we go back to our Python example over here, we just gave it 1, 1, 1, and this probably is not the best value. And when we do want to use things in production, we want to see what is the best P, D, and Q values that we can give it to Arima. And in BigQuery, BigQuery is actually taking care of all of this for us by doing this auto Arima equals true, and then BigQuery will do all the hyperparameter sort of tuning, and we'll get the best values that we can use, and we don't have to worry anything about this, and BigQuery will do everything for us. So I think we like auto Arima equals true. Let's leave that as yes. Data frequency, again, we leave it at auto frequency, because if we look at our data here, this is actually daily data, and perhaps maybe there are some other times where we want to look at yearly data or quarterly data. And here, if we say auto frequency, BigQuery will automatically determine what is the frequency of our time series forecast, time series model based on the input data. Now we can also look at this parameter in the documentation. Now, if I look at the data frequency section in the documentation, we can see we can either give it an auto frequency, or we can manually define what frequency we want in our what frequency we have within our data set. And we also have decompose time series equals true, and this is another nice cool feature in BigQuery ML. So if I just look at decompose in the documentation, so we have some information over here. It is true by default. And this is really useful when we get to evaluating or forecasting our model, basically for forecasting a model, because if we have decomposed time series equals true, then in a forecast model, we'll also get additional columns like trend and seasonality that we can use within our graphs or in Looker Studio to actually see what sort of effect these trends and seasonality has on our forecast model. So it's really interesting. So if you want, you can leave this on. these are all the options we have. And then finally, let's give it the data set as well. And so this is our data set here, similar to the query that we had run in the past. So in here, if we look at this, so we have the past date, which is the value that we've given here, timestamp column, and then we have total visits, which is the column that we've given here, and data set, and then group by date. It's all fine. Now, if I do run on this, it is going to create a model in AI data set in my project under Arima GS session. So let's just run this and see what sort of result we get. Okay, so looks like the model has been created. Where we see this button here, let me click on this, go to the model, and of course it has been created over here. And so we have under evaluation tab, we have the P, D, and Q elements and a few other columns over here. And this is really good for us because if we see our Python example where we gave the order of 111 in our Arima model, in machine learning, in Bigquery ML, basically we have Bigquery suggest us the value that we should be using for our GS session prediction that we're doing in this task. The P value is 2, D value is 1, and then the seasonal Q value is actually 3. And when we actually do the forecasting using this model that's been created, Bigquery ML will use this top row value as the best value, and then we'll get the forecast based on this. Now, one of the columns that we have over here is AIC, which is basically a statistical measure that helps us compare all these models and then select the best model among these models. The lower the value, better it is, because it represents a model which is not overfitting or underfitting, and it's basically a generalized sort of a model. So we want to use this, and Bigquery will automatically use this row for the forecasting. So let's actually forecast some values and then plot this in Looker Studio again to see what sort of metrics and graphs we can get. So we'll call ml.explain forecast, and this takes two parameters, the model and the structure. The model itself, we give the model, which is the Arima GS session, which is the one that we gave over here. And the next parameter is a struct with two values, the number of data points we want to forecast into the future. Here we are giving 30 data points. We are saying give us the 30-day forecast, if you will. And we are also giving a confidence level here as well, saying we want 80% confidence. Now, if I run this, so this is a forecasting table. Let me just expand this out a bit, load more. And we see here, these are all the historical data that was used in creating the time series forecasting. So as you can see here, these are all still history. Now, if I go to the last page, you'll see some are marked as forecast, and these are all the forecasted values. Now we can plot this. Let's go back into Looker Studio by clicking on Explore with Looker. So let's convert this chart into a time series chart, and let's add all the relevant fields here. So for the dimension, we'll give it the time series timestamp field. And for the metrics, let's first add time series data. So this is the time series data, and it also includes the forecast here. So let's see what we have in the trend column. I can make this a bit bigger. So this is the trend that Bigquery ML has identified for us. And we can add a few more columns here, such as the predicted lower bound and the upper bound. And we can also add seasonality. So if we say we want to look at seasonality in a weekly time frame, so this gives us the seasonality, and let's add holiday effect, confidence level. Okay, so we have a few things. Let me just make this slightly bigger. So here we have the original values in the dark blue over here. This is the time series data. And as we go from here, where we have the confidence intervals here, so this is what our prediction is as given by Bigquery ML. And the pink line is the lower bound confidence, and the orange line is the upper bound confidence. And in the middle, we have our forecast. And the orange line over here is actually the seasonality, and the model has managed to pick up the seasonality within each week. So this is how we would use Bigquery ML and Arima Plus model. Now, as you saw, it was just a few lines of SQL query to get this model produced and also give us some forecast models. Now, if we want, we can also come in here and understand all the other metrics that are available for us, all the other parameters that are available for us. So this was a good start to do time series forecasting using Arima Plus in Bigquery ML. And we also did a bit of Python as well, just to get our hands dirty with using some of these Python packages. Now, I feel BigQuery ML is a really good place to start the journey where we want to learn machine learning and some of these other models that are out there in our own businesses and in our own lives as well. So now that we have a good understanding of using Arima Plus in BigQuery ML and also the Arima model in Python, I want to look at multivariate time series forecasting with Arima. And for this, we'll also build our own data set where we'll bring in some stock information, stock data, interest rates, and the GDP sort of economic data as well, and bring all those together and then build a multivariate time series forecasting model to understand how changes in one forecast or a trend can influence the forecast itself.